welcome to 9.4, Inscribed Angles. Okay, so we're going to start with Theorem 9.13. The measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. Now, in order to prove this theorem, we have three possible ways we could have an inscribed angle. So this is actually three proofs to prove this one theorem. So the book only shows you one of them, and that is on page 391, and then they expect you to be able to prove the other two based on what they gave you in the first case. So like I said, there's three cases, and you have to, in order to prove the whole theorem, you have to prove all three cases. So let's talk about what that means. The first case is that the center lies on the angle. So here's angle ABC. It's an inscribed angle, and the angle side BC includes the center K. So if that's one case, and that's actually the case that they prove, and they prove that by using another radii and doing a triangle there. So that's considered an auxiliary line, and then all radii are congruent, and then you have the definition of a isosceles triangle, and then congruent angles, and you go on and on to prove that the arc AC is half, that the angle ABC is half the arc angle. The second case is where the center is inside, or is in the interior of angle ABC. So ABC is the inscribed angle, and the center is on the interior. And then we have the opposite, where the inscribed angle ABC does not include the center. The center is on the exterior of the inscribed angle. So we really just need to understand how to use the theorem, and that is that if I have the measure of arc AC is 60, then that means the measure of the inscribed angle is half, which is 30 degrees. So the angle is half the arc. That's how you need to remember it. The angle is half the arc. Okay, so another theorem here is if two inscribed angles intercept congruent arcs, then the angles are congruent. So here's a common way that is used. Arc AC is congruent to itself by the reflexive property. So that means angle ADC is congruent to angle ABC because their intercepted arc AC is congruent to itself. An angle inscribed in a semicircle is a right angle. So let's look at that. Angle ABC, the arc AC is 180 degrees. Well, half of 180 degrees is 90. So that means that angle ABC is 90 degrees, or a right angle. The opposite angles of an inscribed quadrilateral are supplementary. So here I have an inscribed quadrilateral, and the opposite angles, so that would be angles B and angle D, those opposite angles are supplementary. So that means angle B and angle D add up to 180. And angle A and angle C add up to 180. Now for your whisk summary, this is a very short lesson, but it has a lot of application. So that's what you'll see reflected in this video today, is that the lesson was short. There wasn't that much information to be relayed, but we need to practice using it. So I actually have 9 practice problems on here, two different figures. So I know it seems odd, but I want you to really be able to whiz these out, because when we come in class, we're going to work pretty quickly, and I want you to have plenty of practice ahead of time. Please don't forget to submit these through email, and I will see you in class.